Good afternoon, everyone. Thank you for joining us today for our webinar on accelerate the development and certification of smarter drones. So before handing it over to our technical speaker, I would like to give a small introduction about our company, EDS Technologies. EDS Technologies is one of the largest technology solutions providers in India with more than 30 years of business transformation experience. We help transform businesses by enabling adoption of virtual twin, digital analytics, and 3D printing. We have introduced many technologies like 3D printing, VR, digital manufacturing, etc. for the first time to Indian customers. We have established ourselves as trusted partner for more than 2,000 organizations across various industries, including aerospace, automotive, defense, industrial equipment, mining, and more. We have a dedicated regional teams reinforced by our domain and functional consultants, and we are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. We have a widespread presence with 11 offices across India, and we are an end-to-end technology solutions provider to our customers. So our speaker for today is Mr. Srikumar Maganti. He carries a rich experience of more than 23 years in the field of PLM and 3D experience platform, involving technical support, corporate trainings, and customer relationship management. He has worked on-site for numerous prestigious clients to provide the best customer experience. At EDS Technologies, he handles the 3D experience brand and also holds various global certifications from Dassault Systèmes. Over to you, Srikumar sir.
Today's agenda is on making smarter drones, accelerating the entire process of manufacturing a drone, right from concept to flight. So this agenda includes starting with drones or UAVs current landscape, and then what are those strengths and challenges in drones segment. And then we'll also talk about which are those business growth drivers and define success factors, followed by the typical workflow of concept to flight of a drone. And then we focus on mechanical engineering definition, then followed by the validations through simulation approach. And then we have the manufacturing engineering focusing on the shop floor. And we also look at finally the design governance for certification. So type certifications are very important in this particular segment. So how to expedite the process of getting these certifications on time, and how to govern this certification process through our platform approach. Then I will highlight about our customer references, global as well as local. To start with the current landscape, there are multiple types of drones which are classified under 4 stages. Stage 1 to 2, you will find drones for telecommunications, drones meant for asset and traffic monitoring, then drones meant for crowd monitoring. Then we also have environmental monitoring, which is very critical aspect nowadays. Today, you all know the World Environment Day. So if you have to monitor the air quality and climate diagnosing, and also mapping and land surveying, and also wildlife monitoring. So for this, we can definitely make use of drones. And then we have agricultural monitoring, basically for for multi-special imagery and crop monitoring, spraying activities, and then we have precision farming, mapping pesticides and all. So these are all coming under stage 1 to 2 category. Then we have this at next level, we have security and surveillance drones, which is typically meant for military warfare and all. Today, if you see in the recent times, Operation Sindoor was full of the modern warfare using surveillance drones, security and surveillance drones. So in fact, drones were deployed to even attack with the bombers and missiles also. So this is one area which is growing very fast, that is security and surveillance drones. Then comes infrastructure inspection and search and rescue operations. For that also you can make use of drones for rescue operations. So this is all coming under stage 1 and to stage 2. Coming to stage 3, we have logistics and on-demand deliveries. Typically, last mile delivery. If you look at, even Amazon has started with drones meant for last mile delivery. Typically, a drone can deliver whatever is ordered online at your home. So that is coming under stage 3. And then we have medical drones, typically, supplying blood samples, medicine transports, emergency response in remote locations. So this is all coming under stage 3. Then we have at next level we have stage 4 drones, which are basically meant for autonomous applications. It could be warehousing, product sorting, pest detection, spraying. So even spraying also coming under 4th stage. Because it has to be very precise. It is going to take care of the crop. And the search and detect and extract, basically the information or imagery kind of images which you are able to detect and extract and send it back to the central system. That is all done under stage 4. Then we have autonomous UAV, unmanned vehicle safeguards. So again, unmanned aerial vehicles coming under stage 4 here. So this is the current landscape I wanted to highlight about drones and UAVs. And of course, we also have urban air mobility segment, which is coming up very faster now, especially in the metro cities. So coming on to trends and challenges in the drone segment, if you look at the challenges, the flight propulsion is very, very critical. So how much height it can go and travel, and what is the range of a drone, typically in terms of number of kilometers and travel and speed. And also we have automatic stabilization, because it has to also stabilize in the sky, and then it has to adjust as per the weather and climatic conditions. And then remote control, typically you cannot lose any kind of contact with the drone. So some of the challenges could be remote control and then autonomous navigation. So drone should be able to navigate through tougher landscapes. These are some of the challenges that you can see. So under UAV subsystems, we focus on actuations and propulsions, variation and control, and typically the communication. And when I say remote control, it's communication, navigation. So these are some of the challenges that you may come across, especially in the drone segment. Again, DGCA, which is Director General of for Civil Aviation. This is the authority which approves type certifications for the drone segment, be it agricultural drones or medical drones, or it could be military surveillance drones. We need to have permissions and certification from this approved authority, so that you can fly these drones for the business purpose. So these are the challenges. Now looking at the growth drivers, today drone segment is growing very fast, and the first and foremost thing is the prototype to certification. So how fast you can go to the market, be the first to do prototype. So that is very, very important today because everybody is looking at market capture. So you need to see how fast you can come out with a design which is tested and validated and also certified. So be the first to prototype. That is very, very important. And then to certification. Then be agile. Basically, once I have proven my drone, which is also having type certification, then I should be able to manufacture that. So how fast I can scale up and then manufacture that, be it make it production ready, ramp up the facilities, and ensure that there is a digital continuity happening from engineering to manufacturing, and also look at the shop floor requirements. Basically, the virtual twin of the factory can be made use and be it operable. Basically, it's typically how effectively you can make use of the infrastructure and operations, and also see a system of systems approach. When I say system of systems approach, typically a drone is a combination of mechanical, electrical, and electronics components. So we need to look at the systems architecture and system of systems approach, what we call model-based systems engineering. So we need to ensure that through mobility experience here, we also need to look at the big data and the data intelligence carried by the drones. So we need to analyze the data, and we should be able to make use of this data effectively. So these are the 4 areas you can look at. And then what is the defined success factor is you should have the digital continuity from concept to flight. So you have started with your idea of a drone, how it should look like, a quadcopter model having, different system of components, and then how do you make an assembly, and how do you ensure that the same design goes through validation as well as manufacturing, and ensure that everyone has the access to the same data, which is a refreshed information or data from the centralized server. So digital continuity plays a very important role in terms of faster time to market. Then comes driven and controlled execution. So typically, you should be able to monitor the projects, understand where we stand in terms of timelines. So the Gantt charts are the task definitions, and then you have to see how the milestones and gates and phases are passed through the projects, and then provide this software as a service. So typically, you can make use of the software as a service as a part of this drone segment to drive this execution. So these are the growth drivers. So we should look at the digital continuity. We should look at the controlled execution with especially with respect to manufacturing, and we should also see how the data intelligence, the data analytics is coming and playing a role in drone segment. So Dassault Systems, with all its 40+ years of experience in the industries, they have come out with a specific industry solution experience for the drones. So it all starts with this platform approach can definitely deliver end-to-end solution for this drone segment. Now, from collaborative innovation to digital manufacturing through virtual twin experiences. So I should have the digital asset, and I should be able to do the complete design, modeling, and simulation. And also I should be able to make use of the same data for manufacturing. And also I should be able to control the timelines through project management, systems modeling. As I said, the MBSE approach for defining the entire system of systems, be it mechanical, electrical, electronics, pneumatics, or any other control systems. Then you play the same experience through the digital asset, that is the virtual twin experience, and we should be able to make use of the data analytics coming through this entire approach, and then making use of this data analytics for the further operations and so on. So we have the end-to-end solution covering all these aspects, be it engineering or social innovation, product portfolio management, project management, requirements management, systems modeling, virtual twin experiences, or sustainability cockpit, and the ModSim approach. Everything is covered from engineering to manufacturing for the drone segment. So Dassault Systems has come out with a complete solution for the drone segment to make it easier for the customers to run the entire solution from concept to flight, and also passing through the type certifications. So if I look at the typical workflow, so this is the typical workflow that you follow in terms of market study, and then we have as a part of market study, we need to look at the customer demands. Is it meant for medical drones, basically for the supply of medicines and blood samples or any other patient requirements, or is it something with respect to surveillance, survey maps, survey mapping of specific area? Is it something with respect to competition analytics or idea finalization? Everything will run through this market study first. So once we have the idea, say if you take example of agricultural drones, so a specific volume of a container should be able to spray, say 100 liters of fertilizer in a crop. Then we define the idea there, and then accordingly we start with the concept design. So as a part of concept design, again we can run through concept creation iterations. Then we need to define the functional and technical specifications. and we need to review the concepts, and finally you approve the concept. So once you have the idea of a concept of a, say, agricultural drone, then you look into the detailed design. So from preliminary design to detailed design, you translate the concepts into design process workflow, finalize the detailed design, then you run through the digital mock-up of this. So when you run through virtually on the software, the digital mock-up, you will definitely come to know like what kind of constraints are there, and whether our design is feasible for manufacturing or not. All those aspects will come in. So once you have this definition of digital definition, then you move into digital validation, where you specify the materials, be it aluminum or steel, or it could be composite materials, alloys. So what is suitable as per the functional definition? Suppose if you are looking for survey and surveillance drones, basically on the country's border, then you need to look at composite materials as an option, because your drone should be able to meet the demands in terms of flying across the border. So it should not get destroyed. It should be robust and should be having thermal resistance and corrosion resistance and all. So you look at the composite materials as a selection. So as a part of digital validation, you look at the materials, you do the structural integrity and validation, you optimize the structure, and then you finalize the structure for the digital validation. Then you move into from simulation, you move into prototyping. So as a part of prototyping, so again you develop the first concept into a prototype. Then you have to run through the type certifications. So DGCA will run through the trials. Your simulations which are run in the past will definitely be helpful for the DGCA to approve your type certifications. So once the type certifications are gained, then you can start looking into the production immediately. So as a part of this production, again, you look at the process planning, facility planning, factory flow simulation, machining, robotics, ergonomics, and all the manufacturing solutions that will come in. Then finally, once you launch this product, then you should be able to provide the virtual twin experience to the customers. Again, the distribution plan, post-launch survey, and corrective actions. So this is how the typical flow of a drone from concept to flight. So Dassault Systems has focused on this particular segment, with a scalable approach, wherein we are able to track the entire organization with respect to different teams first. So we have design and engineering team, then we have simulation and program team, then we have program management, then we have production team, that is manufacturing engineering team looking into the production, and also we have certification team which is focused on gaining the type certifications. So these are the teams which are going to work in collaboration using our solution. So design and engineering team, they will definitely focus on the structure. Again, there are multiple parts associated within the drones: sheet metal, machine parts engineering, then we have composites. Then we look at the continuous product development. As we move on, we need to look at the digital validations, digital mock-up definitions first initially, and we should be able to arrive at the right design from this team. Then comes validation of trade-off through simulations. Obviously, you need to simulate virtually first, because you want to reduce the number of prototypes, and you want to ensure the time consumed by the design should be shortened. So you run through multiple iterations of simulations first. You run through trade-off studies and finalize the design. Once the design is finalized, you look into promoting the concept to internal and external stakeholders. Again, you should be able to provide the virtual twin experiences to the stakeholders. Then from program management, you move into manufacturing engineering. So here you look at assembly process engineering and virtual build, and also you need to look at the plant layout, the production line pre-studies, process planning, and so on. If you are using 3D printing as an option, then you need to look at again additive manufacturing approach for this, some of those drone components. Then you need to look at design governance for the certifications. So type certifications matter a lot. because without this you can't fly your drone in the sky. So you need to gain this type certifications after the first prototype is built. Then once you have the clearance from the DGCA or any other approved authorities, civil aviation authorities, then you can start the production. So in this entire workflow, you will see all the teams collaborating, be it a design and engineering team or simulation team, program management team, or it could be manufacturing engineering team from the shop floor, or it could be certification team, which is again connected with the certifications. So everyone has to come together, collaborate, and ensure that you are able to come out with a right design at the right time, and you are able to do the start of production immediately. So I'm going to take you through some of these processes one by one. So if I have to reduce this design time of a drone, then I need to look at some of those knowledge templates which can build this entire drone design in very few steps. So in this example, I want to highlight a quadcopter building basically, which I can do that in very few steps by defining the specific parameters and attributes. So I start by my quadcopter process with capturing the requirements first. So if it is a surveillance drone or if it is a specific survey mapping drone, we need to look at what kind of satellite positioning, what is the kind of flow and landing, and what kind of cameras have to be fitted into this drone. Then again, we need to look at payload and weight, and all, because the material also what you choose matters in terms of drone, because the based on the payload and flying capabilities only the type certification is given. So by making use of this particular template, what we call quadcopter builder on 3D experience platform, I am able to come out with a proper solution based on these parameters. Now I can also look at the propeller shaft, propeller pair basically. So this propeller pair also I can choose from the existing libraries which are readily available, and then you can pick up the right one, and you have the structure which is actually carrying the entire drone, and this structure is ready with the help of knowledge-based engineering in CATIA. So once you have that, you have the structure, and then you have the electrical components, the motor, actuators and sensors, with the video camera positioning and fitting. Everything can be done in very few steps. So we have the built-in CATIA libraries to do all this. You just have to run through this knowledge-based engineering and build this entire drone with the kind of fittings coming and components coming from catalogs. So it's easier to come out with the basic design of a drone or UAV in this fashion, and later on you can also modify this as per your requirements. So by doing so, if I have a template to create this kind of drone in few minutes or say 1 or 2 hours, then I am saving a lot of time in terms of the design activities. So faster time to market will improve, and then I'm able to come out with the basic drone definition. Later I can also modify this as per my requirements. So this is the first step in terms of collaborative mechanical engineering definition. Then comes, I look at the kinematics. Obviously you need to look at how each and every component in motion is working. So we can using CATIA kinematics, we are able to define all the multiple joints and we are able to work on. So in this example, we are trying to highlight all the multiple joints, be it revolutionary joints or revolute joints or prismatic joints or universal joints. We are able to define them and run through the mechanism motion and with respect to length, time and angle. So for this flight propulsion and mechanism in the motion, kinematics, CATIA kinematics will definitely help a lot. So in this example, we have used 3D Experience CATIA to build these components, assemble them, and create those joints based on the constraints. So once constraints are defined well, then I'm able to come out with all the joints Then I will arrest all the degrees of freedom, and then I can run through these kinematics without any clashes, and also see the whole system's behavior in this fashion. So this is what I want to highlight about. Now, this is another example of a pylon motor, how the kinematics can play a role. We can actually check and validate the entire kinematics motion in this fashion. I will just rerun this because this is how the the rotary blades will come out and then start rotating. So the propeller shaft, you can see that. So this is how we can study this motion effectively. Then I can also look at the overall weight perspective. The weight and balance manager role on 3D Experience platform will ensure that what has been defined in terms of weight. So when I look at the business intelligence essentials, then I'm able to see the weight definition as well as weight distribution. So in this example, if you have not defined the weight, or if you have not declared the weight, or if you have not computed the weight, then it is going to highlight this fashion. So if you have any materials missing, or if you have not declared specific weights for specific components, then this business intelligence essentials will ensure that you need to provide all the values in the right way, and ensure that the entire weight of the complete drone is well defined, because this is going to be a very important element in terms of type certification, because the weight and the payload and also the propulsion, these are the three important characteristics on which the drone is certified. So this particular weight and balance manager will help you to run through this kind of business intelligence and provide you the right inputs and details on the weight management. Then I move into a specific area of composite segment, because composites provide the lightweighting part, lightweighting of the components. It also provides durability, longevity of the component, and also is thermal resistant, corrosion resistant. It has got very peculiar properties to support the flight operations. So in this example, I'm going to highlight how CATIA composites is utilized for the drone segment. So if you look at the blade design, this is all done through the composites. So you can see the ply sectioning involving different types of materials, be it carbon fibers or Kevlar or aluminum. We can highlight all those materials here. The complete stack up and sequence is well defined in such a way that you are able to come out with the complete isoparametric thickness of a given component. In this case, it's a blade which is well defined. Now we can define the complete composites design under CATIA, and we can come out with the ply shapes and patterns which can be run for whether nesting cutting operations or further manufacturing operations. So this is how composites CATIA will help you to start from preliminary design to detailed design to manufacturing preparation. Again, you can look at ply sectioning, core sampling, numerical analysis, and also you can come out with a ply book, basically the developed shapes, ply shapes, along with their orientations, materials, and the ply thickness as well as ply area definitions can be captured easily by using CATIA composites. So this is one example I wanted to highlight about composites engineering, and then we can also look at the lightweight engineering benefits for the drone segment. So obviously, if you have to improve the flight time and efficiency, the drone has to be lightweight and it has to be strong. It should be again, the payload capability should be more like in terms of to carry sensors, cameras, and other mission specific equipment, and it should be easily maneuverable. Typically, you need to look at the pitch and yaw, and also agile flight and precise control operations, and also the durability of all these components with respect to varying weather conditions. So as a part of this, lightweight engineering is very, very critical for the drone segment. Now, I will take an example of how CATIA has evolved over the years to provide lightweight engineering we have started with computer aided design we call CAD, but today we are talking about cognitive augmented design, which is basically like you are combining the aspects of design, simulation, and also the optimization of design in such a way that you are able to do the topology optimization and reduce the overall weight of the component. So I'll take you through one of those examples here. In this case, if you see, the initial component is something like this. Now, if I have to come out with the best design, how do I look at all the functional constraints, the actual definition of this component from the design perspective, and also the fulfilling the requirements? I need to keep the materials I need to look at, and then see how the topology optimization can be done. So CATIA offers something called function-driven generative designer role. Using this, you are able to define all the constraints, say with respect to clamping conditions, loading conditions, pressure distribution, and also you are also able to come out with manufacturing constraints. So once you define the manufacturing constraints, whether it is from the milling perspective or casting perspective, or it could be something from the additive manufacturing 3D printing perspective, we can define those manufacturing constraints also apart from this regular definition. Then software will run through the algorithm and it will come out with a typical shape which is also meeting all the requirements, functional requirements. It is able to manage everything. At the same time, this will highlight the areas where there are no stress concentrations, no pressure involved. So we can remove all those areas with the help of subdivision surface technology, and finally we can come out with a specific component, something which is like this. So the initial component is a solid block, but software is able to guide me through this and then come out with a really good aesthetic shape, which is also lightweight in nature, which is able to reduce at least 30 to 40% of the weight. At the same time, it is able to meet all the functional requirements. So in this case, again, I can run through the iterations. I can set up these manufacturing constraints as well as the regular simulation constraints, and then I can run through the iterations with respect to different manufacturing aspects. As I said, if you are doing machining, again, what is the kind of approach? So in this example, we have run through 4 different types of approaches. The shape validation is done with respect to machining, milling, and casting, or it could be 3D printing. Now, based on the type of manufacturing constraints, I am able to arrive at a new aesthetic shape for a given component. The initial component is on the right side. As you move on, you come out with the best aesthetic shape with the help of this topology optimization in this example. So finally, I can reduce this the total weight of this particular component, say by 40% or 60%, based on the type of model it is, and then we can arrive at the best aesthetic shape as per the requirements. So this is, again, as I said, it is a cognitive augmented design, which is using artificial intelligence in the background, which is able to come out with the topology optimization with a new shape, which is more aesthetic and which is also lesser in weight at the same time, which is very efficient in real conditions. So this is how we come out with, in this example, with a final iteration, and then we settle down with the component of a bracket like this. So as you can see here, the basic component, legacy component, is 414 grams. The by-to fly ratio is 8:1. When it comes to the comparison, now the weight is reduced to 78% of the original. The by-to fly ratio is 14:1. Now, when I make use of additive manufacturing, then if I go through that process, I can reduce the weight by 55%, where the by-to fly ratio is 1.3:1. So there is very minimal usage of the material in case of ALM. So this is how I can arrive at these shapes quickly using CATIA function-driven generative designer role, and then we can ensure that all our drone components are able to meet the requirement, at the same time very light in nature, making use of different types of materials and properties. So here are some of those examples where we are able to come out with more aesthetic as well as lightweight shapes which are 100% functional. Now I move on to, from the design, I move on to the simulation aspect, because unless you verify this, the structural integrity, durability, fatigue, and optimization, whatever you want to run in terms of analysis, there are tools which are part of CATIA, 3D Experience platform, where you can move this design to simulation seamlessly within the same user interface. So be it stress, strain, graph, or deformation, then you can look at fatigue and durability analysis, damage and failure analysis, because when a drone is flying, there are multiple different conditions. Again, the varying weather conditions, we need to look at all those aspects and see whether our design is withstanding all this or not. So we can run through all these simulations effectively. We can come out with a proper topology optimization in the lightweight structure, again using the specific materials, and then we can ensure a design which is robust as well as which is durable and which can run long term. So we have all the tools to do the simulations, be it linear or non-linear analysis, again structural, thermal, composites. We can run through all kinds of simulations. We can do trade-off studies. We can come out with the right results in such a way that we can prove that yes, our design is very much capable of meeting all the requirements and also for future scope as well. So these simulations are very, very, very important for the type certification, because when you approach the authorities, they will look at the simulation results which you have done virtually. So based on the simulation results, and then they will also look into the physical testing later. So this process will ensure that your design is robust, as well as it is able to meet all the requirements, at least for a specific number of years. So this approach is basically the ModSim approach. Why we are giving is that today, if you see most of the companies, they have different softwares for different elements. Whether it is for design, we have separate software; for simulation, we have separate software; for manufacturing, we use separate software. Then there is no integrity, continuity, digital continuity happening between these departments. So and also the time for data exchange is very, very high moving through these departments. So we can reduce all that by having one single platform wherein you will run through design, simulation, and manufacturing seamlessly in such a way that everybody in the organization has the same latest information or data at any point of time. So that's what we call the digital continuity happening through this platform approach. So in this, I will take example of battery module and pack systems engineering. The battery analysis is very important from the thermal performance perspective. So we can run through battery thermal management simulations in this fashion. So we can look at the von Mises stresses. So we have a battery pack here. You can run through the simulations. What kind of the cooling element that is coming in. You can also look at the real-time flow of analysis here. At the molecular level also, we can look at how the materials, especially the lithium ions, are operating at, and we can calculate the concentrations. We can also run through different types of analysis with respect to even electromagnetic radiations and so on. So we have all the tools to run through these simulations. I just took one example with respect to battery and battery module and pack, battery pack simulations. So as from modeling to design to simulations, you move seamlessly. Then you come into manufacturing engineering. Again, using the same user interface on 3D Experience platform, you will be able to run through the entire assembly process simulation and also the entire factory flow simulation in this fashion. So this is the virtual factory, which is our digital asset here now. So you can see the complete virtual factory operations. Entire plant layout is done here. You can also see how the equipment, the resources are positioned Then you can look at the 3D process planning. You can define every step and sequence of an assembly, and you can also highlight timelines, Gantt charts in this fashion. This is basically the complete digital manufacturing, which you can do that in using Delmia 3D experience. So within the same platform, you are just seamlessly moving from design to simulation to manufacturing. And you can also order these components online. I mean, we have a connectivity with the marketplace, and you can also order any of those specific components online as well. So this is something which we can do through manufacturing engineering. So again, it's the same interface. You are actually moving from design to engineering bill of materials to manufacturing bill of materials. From there, you start with the PPR, that is product, process, and structure resource model, and then you enter into process planning, assembly simulations, robotics. If you are looking for 3D printing, you can also bring in that. We have additive manufacturing roles to meet the requirements for 3D printing as well. So this is all happening in the same user interface. This 3D experience platform will provide you the single source of truth. Again, for all the stakeholders in the organization, wherever they are positioned across the country or even outside the country. So this is the important aspect of platform approach. And then you move on to certification process. Basically, there should be a design governance for the certification, because the same thing is being asked by the DGCA authorities here in India. So we need to run through the certification visual testing. So I can provide the simulation visual testing results in this fashion. So I have already defined my template for the certification process. So agree on the type certification basis, initiate the certification process, then followed by specific special conditions, proposed deviations, and then you run through the certification visualization testing, because this is going to help the simulation results what you have come out with respect to flight and propulsions. You can definitely highlight these results for getting this type certification. So in this case, I can showcase all the simulation results to the competent authorities. I can showcase the complete visualization testing. So that removes some part of burden, and then you move on to physical testing and flying conditions later. So this way, we ensure that the certification process is well managed within the platform, starting from design to simulation to manufacturing to certification. So everything is covered under one single umbrella. So that is how Dassault Systems is providing the complete end-to-end solution with respect to drone segment. So coming to the end, like these are the benefits. Like when you are on 3D experience platform from Dassault Systems, you are seamlessly connecting all the value streams, be it design, engineering, and or manufacturing or certifications. You are bringing together or integrating them together on a single platform with the same user interface. So the efficiency, engineering efficiency improves by leaps and bounds. You are able to remove all the non-value added activities. It could be data exchanges, or it could be meetings, or it could be mail exchanges. All those things can be removed by having this kind of platform approach, which also provides a stable digital continuity. Then you can also reduce the number of prototypes cycles, basically by having this modeling and simulation approach coming together. So if you are updating the design, automatically the simulation is also getting updated. So you don't have to do the data exchanges between the departments. This will ensure that you are able to reduce the overall number of prototypes by at least 40%. And this is the ModSim approach, what we call integrated modeling and simulation approach we offer through the platform. Then comes complying to quality and compliance standards. So again, as I said, you can set these standards in the beginning of the project itself. You can set those standards in the project template itself and ensure that these standards are followed throughout the process workflow. Then we are ensuring the digital continuity across all the organizational barriers. So be it design department or simulation department, or it could be manufacturing, or it could be even procurement, finance, purchase, HR. We can also bring in the top management into the platform ensure that every stakeholder has a visualization of what is happening in 3D environment in the 3D language of communication. So this is something possible as a part of this platform approach. And more importantly, the last point, securing the certifications on time. As I just showcased an example of how you can fasten the process of certification by having the certification visualization testing results. We can showcase it to the concerned authorities and see that we are able to accelerate the certification process and see that you are the first one to come onto the market, and also you are able to meet all the requirements. So these are some of those benefits using this platform approach. So be it design, simulation, manufacturing, quality, or it could be the production, and also even the virtual twin experiences, the after field sales service operations, and also the data intelligence and data analytics. Everything is covered under one single platform approach for the drones or UAV segment. So here are some of our global references which I'm talking about. So already the global aviation industry working in drones and UAV segment or urban air mobility, they are already working with CATIA and Delmia brand of 3D experience solutions. And you can see, many companies, and there are so many other companies as well, like TerraFusia is coming out with the amphibian space wherein it can fly as well as it can travel like a car as well. So some of those aviation examples are highlighted here. Joby Aviation, Vertical Aerospace. Then we have Autoflight, Embraer Aviation. Then we have John Horizon. There are so many global companies who are coming out with very, very high innovative ideas using this 3D experience platform approach on cloud. So here are some of our India references where we have worked through, like Dassault Systems or RAFE Amphibier is one of those companies providing military surveillance drones, and these are the same drones which are flying on the Pakistan border. Again, they are manufacturing in Noida in Delhi. And then we have Garuda Unmanned Systems. Vanvili is the brand of their, drones. Then we have a farm robo from Hyderabad who are into, the unmanned, farm robotics, basically farming done through this unmanned aerial vehicles. Then we have General Aeronautics Bangalore, Magic Maina from Coimbatore, Throttle Aerospace Systems for medical drones, Dhaksha Unmanned Systems for agricultural drones, again Ali Aerospace. So we have been working with these drones companies in India. These are all, again, they are aspiring for DGCA type certifications, and also already some of their variants are in the market and providing a lot of emphasis, new emphasis in this particular segment. So if you have any specific questions relevant to this drones or UAVs or urban air mobility segment, kindly let us know. We can work with you closely. We are actually offering something called a startup offer for this particular segment. We can actually provide our solutions at a very low price as a part of startup offer for first 3 years. So some of these companies who you see on the screen, they have availed the benefits of startup offer, and they are able to work through their assets. So this is what I would like to highlight in terms of meeting the requirements, accelerating the entire process of smarter drones from concept to flight with these examples.
So I would like to thank you, Shikumar sir, for delivering a very informative webinar. I am confident that it was helpful to our audience as well. I would also thank our audience for taking their time out and joining us for this session. So as sir mentioned, if you have any further queries related to the subject matter or any other requirements, you can always connect with us. Our details are displayed on the screen right now, and you can reach out to us at any time and we'll be happy to address your queries. So please do keep an eye out for our upcoming seminars and webinars. You can follow us on our social media for the same. Thank you once again for joining us today.